Welcome back to our virtual lab for this week. We're lab 8. We're on the homeward stretch here. So we're going to be looking at force production using our Biodex Dynamometer. Now, if you listen to the lecture video, hopefully you got a little bit of an understanding about how the dynamometer works. So for this first video clip, we have a very special participant today. Can't wait for you to see who it is. But we're going to be doing 10 repetitions at each one's going to be different velocities. We're going to be doing 180 degrees per second, then 210, 240, 270, and 300. And then we're going to work our way back down. So 300, 270, 40, 210, and then 180. What I really hope you notice is how fast the machine is allowing the participant to work. And so based on what I told you in lecture, hopefully you can kind of understand the force produced at the varying different velocities. So go ahead and watch the lab video. I'm going to talk about halfway through this lab video, and then I'll also talk at the end, just give you a little bit of an understanding of what's going on, and I give you a little bit of an explanation about what's happening in this first little clip. So go ahead and watch it, and I will see you throughout and at the end of the lab. All right, well, welcome back. We're going to be doing our isokinetic test today on the Biodex Dynamometer. So I've got it all set up. If we were in lab, I'd take you through this a little bit more, but unfortunately I can't do that. So we're going to be testing the right leg today. So hopefully I've got myself all set up correctly here. One thing that is going to change is normally I would have a harness on, but it's a little tough to work the computer and the chair as well. So values might be a little bit higher than normal just because I can use a little bit more of my upper body, move it forward. I'll try not to, but that just might be the case. And so we're going to be looking at velocities in this one. So we're going to be doing 10 different reps. We're going to be starting at a slower velocity, do 5 reps where we're increasing our velocity, and then we're going to have the last 5 reps, we're going to be decreasing that velocity. So we're going to start at 180 degrees per second, then we're going to go to 210, 240, 270, and 300 degrees, and then work our way back down. And so we'll see what happens with force production when we are controlling for the speed and how much force I can generate at each different velocity. So tighten myself up here and we'll see what happens. So wish me luck. So here we go, this is going to be the fastest one. So we're at 300 degrees per second now. So we've worked our way up, now we'll be working our way back down. So we're doing another at 300 degrees per second. 270. 5-second rest. We're going to 240 degrees per second now. Second rest. Now we're doing 210 degrees per second. And our last one, 180 degrees per second here. So there's the test. We'll get the output values and we'll talk about it here in a second. Well, hopefully you found a difference in the velocities of that last video there. So we worked our way up to a faster velocity, then worked our way back down. Now obviously I can't show you the forces produced on the screen, so you're gonna have to look at the lab write-up for that and the output produced. For this next little clip, is a very, very short clip, but what we're doing is we're 10 repetitions at 60 degrees per second. And what we're doing is we're measuring the force throughout the entire duration of that movement. So with the Biodex Dynamometer, we can control and make sure that we are only moving at 60 degrees per second for the entire duration of the movement. And then we can measure the amount of force that is being produced from an extreme flex position to an extreme extended position. And so for this one, we're looking at that length tension relationship, which I told you about in the lecture. So go ahead and watch this last little bit. Again, quick 10 repetitions where we're measuring the force produced at different angles or at different lengths of the sarcomere there. So enjoy, and I'll talk with you again here in about 30 seconds. Well, hopefully you have an idea now of how that isokinetic dynamometer works. And so with the isokinetic dynamometer, we have the same velocity happening throughout the range of motion, and then we're just measuring the force produced at that varying degrees. So for your lab write-up, there is a document posted to Blackboard, obviously, but you are going to be answering 2 questions. Part 2, or second question, has A through D. Again, answers C and D. Literally looking for one-word answers, especially for question C. Question D, maybe 2 or 3 sentences. For the output values, they're all listed on your lab sheet. So you're gonna have to calculate that agonist-antagonist ratio, or that hamstring to quadricep ratio, which we talked about in lecture. And then for the length tension relationship, there is a document posted there which has the output numbers and then the graphs that are, or that were outputted by the computer there. So just have a look at that and really just decipher what the shape of the curve looks like. There's no calculations regarding this one with the force produced and the length of the muscle as well, or where we are in the range of motion. So if you have any questions, again, let me know, shoot me an email, and I will get back to you as soon as possible. Otherwise, I hope you have a great week and not too many more to go. So well done on making it this far, and just a couple more to go.